Hello, this is Chris Chappa, math professor at Tyler Junior College, and this is the solution for the logic puzzle in the first week of Math Month 2022, the Kuramasu puzzle. Just to give a quick recap of how it works, we're going to shade some squares so that each number counts the number of unshaded cells it can see, horizontally or vertically. Squares with numbers cannot be shaded. Shaded cells cannot touch horizontally or vertically, but may touch diagonally. All unshaded cells must form a contiguous area. In other words, it's possible to travel horizontally and or vertically between any two unshaded cells without being obstructed by shaded cells. Excuse me, I did label the columns A, B, C, D, E, F, G, H, I, and the rows 1, 2, 3, 4, 5, 6, 7, 8, 9 for reference purposes. So how do we solve this? Well, the first thing is that squared numbers cannot be shaded. So I want to indicate that they're unshaded by filling them in with a color besides white. I'm going to fill them in with yellow. So every square that has a number in it, I'm going to click and fill in yellow. And I'm just using Paint 3D. It's I think it's with most laptops, most PCs. All I did was do a screenshot of the PDF and copy this part of it. Let me see if I can zoom in a little bit more. We lose the instructions, but that's okay. All right, now that we've done that, the next thing we want to do is either look for small numbers that can't see too far or large numbers that must see really far. For example, look at the 14 in cell F1, column F, row 1. That 14 has to be able to see 14 cells horizontally and vertically. If it looks left and right, it can only see a total of 9 cells since it's a 9 by 9 grid, 9 cells including itself, but it's got to see at least 14. So going down, starting with cell F2, I can count up until I hit 14. So 9 cells it can see going across, and then going down 10, 11, 12, 13, already shaded in 14. And sticking with the 14, we know that it can only see 9 cells vertically and 3 more cells to its right. The 9 going vertically is 9. Well, going vertically is 9, plus the cells in G1, H1, and I1 are 3 more. 9 plus 3 is 12. So counting to the left, 12, 13, 14. The 12 in cell A8 in the lower left corner, similar. Moving vertically, it can see almost up to 9 cells. So start counting with 10 moving to its right in cell B8, 9, 10, 11, 12. And focusing on the A8 again, the 12 in cell A8, it can only see 9 cells horizontally and 1 below it. 9 plus 1 is 10, counting upwards, 11, 12. Let's also focus on the 12 in cell E8 in the bottom center. It can see 9 cells horizontally, plus the one below it is 10, upwards is 11 and 12. Well, those are already shaded. Let's look at the 12 in cell H6. In cell H6, this 12 can only see 9 cells vertically, plus 1 to its right in I6, so that's 10, and then counting to the left, 11, and then 12 is already shaded. Similarly, with the 12 in H4, it can see 9 cells vertically. 1 to the right is 10, and then to the left, counting from 11, 11, 12. As far as the rest of them, maybe this 13 in E6 can give us something. There's 9 cells going horizontally. Below it would be 10, 11, and 12, so it has to see one more above it. But I think we've just about exhausted, at least currently, all of the large numbers. Now let's focus on some of the numbers that already have a lot of unshaded cells around them. Actually, I want to focus on one more number. In cell C9 at the bottom, the 9 at the bottom, granted, it can only see 9 cells horizontally and doesn't necessarily look vertically, although it sees the one above it. However, notice this 3 in H9. If the 9 in C9 were to see all the way to the 3, then that would be bad for the 3 because the 3 now sees too many cells. So let's undo that and think about how far the 9 could see horizontally. It can't reach to the 3, so it could only see 1, 2, 3 itself, 4, 5, 6. It could only see 6 cells horizontally, and so counting up from 7, 7, 8, 9. All right, now let's look at some small numbers that have a lot of cells shaded around them. I'm looking at the 5 in D7. The 5 in D7 currently sees 4 cells. Itself, the one to the left of it, the one below it, and the one to the right of it. It can only see one more cell. Well, what would happen if it looked further to the left? In other words, what would happen if B7 was unshaded? Now the 5 sees too many cells. It sees 5 horizontally plus the one below it is 6. That means B7 cannot be unshaded, which means it must be shaded. And since it's shaded and shaded cells cannot touch vertically or horizontally, the cell above it, B6, must be unshaded. Okay, who else currently sees a lot of cells and maybe can't see anymore? I'm looking at cell F5, this 7 right here. Notice that it currently sees 7 cells, starting at F1 above it, 1, 2, 3, 4, 5 itself, 6, 7. This 7 already sees the maximum number of cells that it can see. So what we're going to do is circle the 7 to let us know that it is done. It can see everything it sees, and it can see no further in any direction. Cannot see further to the right, so G5 has to be shaded. Cannot see further down, F7 is shaded. Cannot see further to the left, D5 is shaded. And now that I got all these shaded cells, we can unshade the ones adjacent to the black ones. So D6 is yellow, G7 is yellow, F8 is yellow. And now let's go back to the 5 in D7. Notice that the 5 in D7 currently sees 5 yellow cells, including itself. It sees itself, it sees the one above it, below it, to the left and to the right. So that 5 is done. It can see no further in any direction, and specifically no further down. D9 must be shaded, which means E9 to its right must be unshaded. Now let's look at the 8. The 8 in E7 is blocked in 3 directions. It can't see any further right, left, or down. Let's see how many cells it has. It can see how many more it needs. It can currently see 5 vertically from E5 down to E9, plus the 2 more to its left. So the 8 currently sees 7 cells, but it needs to see 8. And the only direction it can see an 8th one is above it. E4 must be filled in, and it must be blocked off in E3 by shaded cell. So we can unshade E2 and D3 and circle the 8 red because it is done. Now I'm looking at the 13 immediately above it, because the 13 above it can no longer see any further up, down, or to its left. So if it's not full, it must be to its right. Let's count how many cells it can see. Let's start vertically. 1, 2, 3, 4, 5, 6. To its left, 7, 8, 9, 10. To its right, 11, 12, 13. The 13 now sees all of its cells. It cannot see further to the right, so I6 must be filled in. 13 is complete. We'll circle it. That's just so I know that I'm done with that. And the shaded cell in I6 is needs to be unshaded above and below it. And at this point, it's just a matter of finding all the right places to look. Where's the next place that I should look? I think I'm going to look at the 9 in C9, because the 9 in C9 can only look 2 spaces to its left. So if it were to look to its left, it would see 1, 2, and n itself is 3. Start counting up until we hit 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's see. What else can we capitalize on? I'm looking for numbers that are blocked in certain directions. The 7 in G3 is interesting because it currently sees 4 cells. Itself, the one below, the one to the left, the one to the right. But it has to see 7, and it's blocked to the left and to the bottom. So let's see what happens if it looks completely horizontally. Horizontally, this 7 can only see 4 cells, plus the one below it is 5, moving up is 6, moving up is 7. And now it currently sees 6 cells, 4 vertically, 1 to its left, 1 to its right, needs to see 7. There's the last one, and that 7 is done. Now let's focus on the 3 in I2, because it can't look very much further. The 3 in I2 currently sees two cells, itself and the one below it. If it were to see one more below it, now it would see too many, it would see 4, which means that can't be unshaded, which means it must be shaded. And if it looks to its left, now it sees a lot of cells, 1, 2, 3, 4, 5, 6. So it can't see any further to its left. That's shaded. The one above it is unshaded. The only other place for 3 to see its third and final cell is above it, and that completes the number 3. Let's look at the 8 in H3, and there's no correct order to do these. I'm just going wherever I see hints. The 8 can see no further up, left, or right. So to complete what it can see, it must see it down. It currently sees horizontally 1, 2, 3, 4, counting downwards 5, 6, 7, 8, 8, 8. Oh, I didn't click fill. 8. And that maxes out the 8, which puts a shaded cell at H8, which has to be unshaded on both sides of it. The 8 is finished. We'll circle it. The 12 below it is now obstructed view in 3 directions, up, down, and to the right. So we should be able to finish that off. Let's get ready to shade in some more. This 12 can currently see vertically 1, 2, 3, 4, 5. So counting to the right, starting with 6, 6, 7, 8, 9, 10, 11, 12. That 12 is done. It sees all it can see. The 6 below it can also see all it can see, as can the 12. You can count if you don't believe me, but none of those can see any further in any direction. Let's go to the 14 back at F1. Its view is obstructed going up, to the right, and down. It can see no further in any of those directions. So we just need to see if we have a total of 14, and if not, bring it up to 14. Down vertically, including itself, it sees 6 cells, plus 3 to the right. So that's 9. And now count off to the left, starting with 10. 10, 11, 12, 13, 14. Surprise, surprise, it fills in the whole thing. All right. Let's see. How about the 11 in D4, which can see no further down, to the left, or to the right? So if it's not 11, it's going to have to fill in D2. 1, 2, 3, 4, 5, 6, 7, 8 horizontally. Going up is 9, 10, and 11. The 11 is done. Let's see. How about the 12 in E8? The 12 in E8 better be told up to 12. It can't see any further. Horizontally, it sees 1, 2, 3, 4, 5, 6, 7. Going down is 8. Going up is 9, 10, 11, and 12. Good, because there's no more for it to see. Let's look at the 12 in A8. The 12 in A8 currently sees 1, 2, 3, 4, 5, 6, 7 horizontally. If it looked down, it could only see one more to be 8. Now start going up, 9, 10, 11, 12. Okay, we should be able to wrap this up real soon. Let's look at C3. This 9 in C3. It can only see, well, it currently sees, going vertically, counting itself, 1, 2, 3, 4, 5, 6, 7, and then the 1 to its right is 8. If it's all the one above it, it would be 9, and then one more above that is 10, which means the one above it has to be shaded. So the only way it can pick up its 9th and final square is to the left, excuse me. 9 vertically plus 1 on either side is, 7 vertically plus 1 on either side brings the total to 9. So that has to be shaded in A3. A2 has to be unshaded. And I think, let's count off the 7. Well, first off, let's circle the 9. Now for the 7 in B2, I'm pretty sure it needs to be unshaded all the way down because it currently sees 1, 2, 3, 4, 5, 6, 7. Fill, please. The 7 is done. And by the way, you can fill this out without analyzing every single thing. I'm just covering all the strategies that I know. For this 9, it would have to, it can only see 7 vertically, so it would need to see the 2 to its left. And that should finish not only it, but the 12 as well in A8, which can see 6 vertically plus 6 more to its right, so it's done. And down to this lonely 3. This lowly 3 sees itself. It can only see 1 to its right, so it must see 1 to its left, but it can't see further to its left because then it would see 4. That's shaded, that's unshaded, the 3 is done, and the puzzle is finished. If you would like to practice more Kuromasu questions, let me show you where I found these. Kuromasu. Let's turn off caps lock. I believe the one that I used was the very first link. Let me click it. I'll know it when I see it. Yep. You can choose the size and the difficulty level. We can go 9x9 easy. We can just close this ad and notice that there's going to be a lot of puzzles because there's 3 pages. If we click number 1, then here they are. You can probably find some more places to do Kuromasu puzzles, but I think they're pretty cool. All right, well, I hope you enjoyed the video. I hope you enjoyed the puzzle, and I hope you look forward to more logic puzzles in the upcoming days.